Let's quickly talk about momentum. Momentum is something which we have been learning since IGCSE. Momentum is denoted by a letter P, lowercase p, and the formula for momentum is mass into velocity, where the unit of mass, SI unit of mass is kg, and SI unit of velocity is meter per second, and this gives you the SI unit of momentum as kg meter per second. Now let's consider a scenario where you're driving a car. The total weight of total mass of the car is m, and the car is moving with a velocity v. Now I ask you that I want you to stop the car. That means the velocity should be 0. The total mass remains same. So I am asking you to change the momentum, because here the momentum of the car was mv and now the momentum is 0. So I'm asking you to stop the car, that means to decrease the momentum, to change the momentum. Now to do this thing, you can do it in two ways. Number one, you can slam the brakes. Now if you slam a brake very quickly with large amount of force from your foot, you will see that the force that you are applying to decrease the momentum is large. That means your change in momentum will happen in a very small time. Now the next thing that you can do, which usually we don't do, is that you just remove gas pedal. So when you remove the foot from the gas pedal, that means your force that is acting to stop the car is only the friction force, which is small comparatively to the brakes. So here the time is very large. And this brings us to Newton's second law. So Newton said that whenever you apply a force on an object, it suffers change in momentum with respect to time. That means if your force is large, your time will be small. If your time is large, your force will be small. That means I'm keeping change in momentum constant. Other way around you can think of is that if you want to change the momentum in a large value, your force should be large. If your change in momentum is small, your force will be small. These scenarios prove this Newton's second law of motion. Now we know that in physics, change is also denoted by delta. So we always come across such notation where F is delta P upon delta T. And from here, my change in momentum can be written as F times delta T, where the SI unit of force is Newton, SI unit of time is second. So the SI unit of momentum can also be Newton's second. Now the question might be arise that we just said kg meter per second. How come we are saying Newton second? That might be a question. Let's try to understand that part. How come these Newton second, 1 unit, and kg meter per second, the other unit be same? Now if we look clearly, this Newton is nothing but the unit of force, and the formula for force that we know, obviously we are going back only here, that is nothing but mass into acceleration, that gives you kg meter per second square into second, and this gives you kg meter per second. So this is how both the units are same. It's just a different way of expressing it. Here this delta P, change in momentum, is also called as impulse. In a very simple sense, impulse is amount of force applied on an object in a given unit amount of time where the time is very small. So impulse is F times delta t, and the unit for impulse is Newton second. That's about impulse for now.